right, today we're going to finish up our first part of this unit with learning how to write proportions and use them in everyday life. We're going to be using proportions a lot over the next couple weeks, probably I'd even say the rest of the year. So this is a good lesson to kind of leap from here. Today's date and page numbers should be added by now, so let's get moving on. So here is your warm-up. I have two tables that need to be completed. And it says McMillan's restaurant is celebrating its 50th anniversary by offering 3 hamburgers for $2. So fill in the first question, which says Sue makes this table to have a reference. And then the weekend goal is to sell 1,200 burgers. They want to know how much money that would be, and they have different goals that they're going to look at: 300, 600, 900, and 1,200. Go ahead and fill those in. Come back when you're done. Remember, this is basically looking at patterns. So look for the patterns that match the tables. All right, so here are the results you should have had. Throughout all the patterns, we know that there were going to be more hamburgers than the amount of money people paid. So as long as our ratio kind of showed that consistently, this is what you should have got. So if you got these both correct, give yourself a pat on the back for doing a good job. So we've talked a lot about ratios to this point, but really what we've been doing, and even since the last unit when you made a table, is we've been taking our thought of ratios and actually looking at proportions. So I want you to write this definition down, and the definition down of proportion, and then the little example here of different proportions. So a proportion is basically an equation that shows two equivalent ratios. So if you have two ratios that are equivalent, that's a proportion. So here in our little explanation here, H2O, which we know is water, is 2 parts hydrogen for 1 part oxygen. So the ratio of water molecules is 2 to 1, 2 hydrogen for 1 oxygen. But if you have multiple atoms or molecules of water atoms, which there's tons out there, they come in these kind of ratios, and 2 of them together make a proportion. So if you were to double your ratio of 2 to 1 to become 4 to 2, that's now a proportion. If you had 4 to 2 and you doubled that to get 8 to 4, that's also a proportion. If you looked at 2 to 1, you multiplied it by 3, and now you have 6 to 3, that's also a proportion. So proportion is basically just two ratios together. Okay? So as long as you got that note down or that little example at the bottom, and that little example at the bottom, you're ready to move on. So we'll start out simple by saying write a proportion for this model. Well, the first thing you can do is you can see that we're doing a ratio of triangles to circles. So when you count out your triangles, you have 4. Circles are 2. So your ratio for this scenario is 4 to 2. 4 triangles to every 2 circles. Now if we created a proportion, all we have to do is look at splitting them up by either finding a number we can divide 4 and 2 by, or multiplying them up. So the one example I have here is I separated them into equal groups. Well, if I'm separating them into equal groups, you know that what I'm doing is I'm finding the unit rate, or I am dividing. So this whole setup is the same as this whole setup broken into 2 equal sections. So in our scenario down here in the bottom, we have 2 triangles for every 1 circle. So our ratio down here is 2 to 1. Now, when we combined our first ratio and we combine our second ratio, which are equivalent because they use the same amount of triangles equally, then that's our proportion at the bottom. Our proportion says 4 to 2 is equal to 2 to 1. So it's just dividing them or multiplying them. Same stuff we did in the last unit or last lesson, is just figuring out an equivalent ratio. So multiplying them equally or dividing them equally. Write down this example before moving on. All right, here is your first proportion I want you to look at, which is dogs to cats. So I want you to make a proportion basically on what you see here, and then make an equivalent ratio, make a ratio, then make an equivalent ratio to have a proportion. Come back when you're done, we'll see how you did. All right, so here we go. I created 2 actual proportions. So I've noticed in both, or if you notice in both, they both start as 12 to 9, meaning For every 12 dogs, there are 9 cats. So the one ratio I decided to change up or find equivalent is I divided them by 3 because I saw that they both had a factor of 3. And I got 4 to 3. So that's one equivalent ratio right here. And 2 equivalent ratios make a proportion. Down at the bottom, I decided instead of dividing, I'm going to multiply by 2. And I got 24 to 18. Again, those 2 ratios together, those equivalent ratios make a proportion. So it should have been a pretty easy one to start out with here. Now there's something new I want to kind of explain to you here, and that's one way you can always tell if something is equal. Now we've done a lot of work with equations. This is a different way that we can use equations to solve problems. So here I have 4 different scenarios where I have equivalent ratios or proportions. I have 4 to 8 equals 2 to 4, 3 to 5 equals 9 to 15, and so on. So what you notice though is that cross products, meaning if you look diagonally, product means multiply. If you multiply them diagonally, the diagonal result should equal the same. For example, 4 times 4 and 8 times 2 both equal 16. So since both sides equal 16, you can prove that these are proportions. The second one, 3 times 15 and 5 times 9 are both 45. So those are proportions because everything is equal when you cross multiply, and so on and so on. So we're going to be using this kind of thought process as we try to work through problems and try to figure out what happens if we have a proportion that's missing a part. For example, if I had 14 to 7 equals x over 1, we got to be able to find out what that x is. Now looking at the problem that's just next to it, if you figure out cross product, cross multiply, 14 times 1 is 14. You just have to figure out what you can multiply 7 by to get 14. And that's how you're going to be able to solve for these problems. So have this down as an example. You can write down 2 of them, or you can write down all 4 of them. All right, so here's a problem that I'm going to have you write down as an example. Here's using cross products to figure out what n equals if our proportion has one ratio that's 3 to 4, and the other ratio is n to 16. Well, how do we find out what the value is? Again, we can use cross products. So find the cross products. That's the first step. So when we multiply 3 times 16, you get 48. And if you multiply 4 times n, we know we can't multiply those together, but we can combine them together because one's a number and one's a variable. So 4 times n gives you 4n. So basically, we have to find out what is it that when you multiply it by 4, you get 48. Well, if we look at what we've got to this point, it says 4n equals 48. Now, we've been doing equations a lot this year, so you know that basically what we need to do is find the value of n. And since it's 4 times n, the inverse operation of multiplying is dividing. So if we go down here, we can see we divide both sides by 4. That cancels those out. And now we can say how many times does 4 go into 48? It goes in 12 times. Now there's some of you that are probably going, well, I already knew that if 3 times 16 is 48, you just had to figure out what 4 is. But I bet what you did in your head is you divided 48 by 4 to figure it out. This is how you set up an equation. So I want you to be using these equations as we move on because it's going to help you as we move forward using proportions. Have this example down before moving on. All right, you're going to be doing 9, 10, 11. If you're comfortable, go ahead and get started. Otherwise, if you want a little extra practice, we're going to do 8. So again, as we just learned, find the cross products. So 3 times d, that's 3d. And 24 times 2 is 48. Now what we need to do is we need to solve for d. So we need to see that the only way to get d alone is to divide both sides by 3. And when we do so, we're left with d on the side. And now we just have to see how many times 3 goes into 48. Well, I know 3 goes into 4 once with 1 left over. and then 3 goes into 18 6 times. So your answer is 16. So I did one with you, and now it's time for you to do the next 3. Your work should look exactly like mine. You should be creating a proportion or an equation, sorry, like 3D equals 48, dividing them both by that coefficient, and then solving. Good luck. These are the answers I hope you got. You can see my work. I created my equation for each one of them by cross-multiplying, and then I just divided by the coefficient to both sides to get the variable alone. 15, 3, and 35. If you got all 3 of those right, come give me a high five. So the third example I'm going to do with you, because it's a word problem one, and I just want you to copy your stuff down in the notebook because I'm going to do it with you. So you're going to have problems like this where you're given data and you have to figure out a proportion. So it says, according to Ty's study guidelines, how many minutes of science reading should he do if his science class is 90 minutes long? Well, looking at his 3 classes he has, the amount of reading that's expected for each class goes as follows. For literature, for every 35 minutes, 50 minutes of class time. So 35 minutes is reading, and the 50 minutes is class time. So the ratio here would be 35 to 50. Okay? Now, we don't care about literature in this problem, though. We only worry about science. So we got to figure out what the ratio is for what we see here. And here we can see that it's 20 minutes of reading for every 60 minutes of class time. So that would be 20 over 60. See how we set up that ratio? 20 over 60. So now what we got to do is we got to figure out what is it that we know and what is it that we need to find out. Well, in the original problem it says, what are we going to do about Ty's study guidelines if he's got a 90-minute long class? Well, the bottom number in our ratio is the amount of minutes in class. So that means what we got to find out is, what should he be reading if class is a 90-minute long class? Now that our proportion is set up, we just need to cross multiply. So 60 times x, that's going to give you 60x. So there's our coefficient and variable. And 90 times 20, it's basically 2 zeros, and then what's 9 times 2, which is 18. So 1,800. So as we've been doing, we got to get x alone. So we're going to divide both sides by that number next to x, which is 60. What you do to one side, you got to do the other. Bye-bye. So now we're just left with x. So now if we divide 60 into 180, first thing I'm going to do is I'm going to see they both got a 0. I'm going to cross that out. Now I just got to see how many times 6 goes into 180. Well, 6 goes into 18 3 times, and then we have a 0 left over. So the question said, how many minutes of science reading should Ty have to do? Ty needs to read 30 minutes for, for a 90-minute class. There's our answer. So you're going to be using this data to kind of figure out all these things in word problems. All right. Now, since I did this one, make sure you copy down the work, and then I will move you right into the box of thought. Here's your box of thought. First one, you're going to tell me whether 7 to 8 is equal to 4 to 14 if that's a proportion. How do you know? So think cross-multiplying. How can you prove it through cross-multiplying? And then give an example of a proportion. Tell how you know that it is a proportion. Done a lot of problems in your homework. You probably, or in your video, you can probably just copy some of those down and explain them. And here's your quiz. I got 6 problems for you to figure out. Go ahead and do your best showing your work. For number 1, you're writing a proportion, so we can already see that one ratio is 6 pencils to 3 erasers. Find something equivalent. Find the missing value for 2, 3, 4, and 5. And then finally for number 6, go ahead and solve that one, that word problem. Good luck. We'll see you next time.